Dear colleagues, it is 9 in Geneva, so we will be starting our second webinar organized by EFTA and UNECE on climate change related statistics for ICA countries. The webinars are organized in collaboration with the National Statistical Committee of the Kyrgyz Republic and UNESCAP. The theme for today is producing climate change related indicators on energy and emissions from SEEA and other sources. My name is Gosia Ćvijek, and I'm responsible for climate change related statistics at UNECE Statistical Division. For the benefit of those of you who did not attend the first webinar we held yesterday, I'm gonna repeat quickly some housekeeping. The webinar will last for 3 hours and have a short break in the middle. In the event chat, you can find a link to the meeting website with the program for today, all presentations in English and Russian, and a link to some video presentations that we strongly encourage you to watch as complementary content to today's webinar. We have simultaneous interpretation in English and Russian. Above the video of the active speaker, you can choose the language you want to listen to. Please note that in this platform, you cannot speak or use your camera unless you're given the floor by the chair. So if you want to speak, you will need to raise your hand, and then the technical host will give you the floor. If you take the floor, please remember to use a headset, speak slowly and clearly, and be mindful of time. At all times, you can use the chat to write your comments and questions. As I said, if you would like to ask a question in person during the discussion time, please, if there is time, we'll give you the floor. If you have any technical problem, please try changing the language channel. Sometimes you need to change it back and forth. Yesterday we had a small problem with the Russian interpretation. Hopefully that won't happen again, but if so, please do write in the chat just as you did yesterday. And if you need any more technical support, you can also write on the directly to our Interprefy technical support using the blue bubble with exclamation mark, which you can see on the top of the chat. And if you think you're having some small connectivity problems, you can also try simply to reload the page in the browser or restart all the lines. So that is all for housekeeping. And just as a way of short introduction to today's session, I wanted to recall that yesterday in the first webinar, we have started the discussion a bit more strategically from how to develop a national set of climate change related indicators and to use it in policymaking. We saw various national approaches presented by Italy, Luxembourg, Switzerland, and Nepal, and looked for common lessons learned from those experiences. Today, we will have more of a deep dive into particular types of indicators that can be produced from SEEA and other sources. And again, we'll be referring to some indicators from the CS set of core climate change related statistics and indicators. So just to remind that this set is a set of 44 indicators, which was developed by countries participating in the work on climate change related statistics under the Conference of European Statisticians. And it reflects a kind of regional consensus of what are the core indicators to focus on. And there is a whole set of materials that supports the implementation of those indicators, including metadata sheets, implementation guidelines, and the report describing how this was all done. The set covers 5 areas: drivers, emissions, impacts, and mitigation and adaptation. Today, we will focus on indicators related to energy and emissions. The indicators on energy are part of the drivers area, and emissions are, of course, part of emissions. As these indicators are certainly of key interest to most of the countries, as they are often the central to climate action policies. And we will start from energy-related indicators based on presentations by Luxembourg, Italy, Mongolia, and Australia. After the presentations, we will have a short break and then question and answer session based on your questions to the presenters. So if you have any, please put them in the chat and we're going to pick them up after the break. After the break and after the question and answer session, we will have a presentation on emission-related indicators by Italy. And finally, in the last segment of the webinar, we will have a panel discussion which will reflect more generally on the use of SEEA for producing climate change-related indicators. And let me also remind you that the presentations delivered during the session are complemented by 2 presentations by United Nations Statistics Division, which have been made available as pre-recorded videos. They are on carbon accounting and ecosystem accounting. And if you've watched those presentations and have any questions related to them, you can also put them on the chat. Unfortunately, due to the time zone difference, the colleagues from UNSD could not be with us today, but we can try to answer those questions during the session, or we can forward them to the UNSD colleagues afterwards. So please do not hesitate to share them. And with this, I would like to invite our first pair of speakers for today. That will be Angelica Tudini of ISTAT and Dr. Olivier Thunus of STATEC Luxembourg. They've been introduced yesterday. So I just remind you that they both led the task force that developed the CS indicator set, and they also have extensive experience from implementing that in their countries. So Angelica and Olivier, you have the floor. I just take away my presentation.
Good morning, everyone. Thank you very much, Gosia, for this introduction. I think that Olivier will go first on this presentation, and I will follow with another pair of indicators. Thank you very much.
Okay, I will share my screen, and we could keep my presentation just after for your presentation, Angelica. Click on that. And normally you should see my presentation and the presentation prepared by Angelica. Then for this first part, we decide to present you some of the driver indicators that you could find in the international list. Well, to prepare this webinar, of course, we need to make some choice on the indicator that we present. And as you certainly see this list of indicators, some indicators are, we estimate, quite easy to calculate. There is no methodological issue. So we focus this time for today on some indicator which could be more complex to understand, and also in terms of methodology, but also in terms of explanation on the storytelling beyond the indicator. So for this first presentation, we'll talk about the indicator 1A, 1B, and also 5A, 5B. So I will take the two first indicator. 1A, this is the total energy use by the national economy. And also the 1B, total primary energy supply. And colleague Angelica will take the two indicator 5A, total energy intensity of production activity for the national economy, and 6A, total CO2 intensity of energy use in production activity of the national economy. As you can see on the slides, this is most of them indicator tier 2, means that the methodology is available for the calculation of this indicator, but perhaps for your country, the data are not available. We also choose this indicator because, as you know, we promote to use economic environmental account to calculate the indicator to follow climate change. And as you can see on the slide, you have the reference of the account that you can use to calculate this indicator. Again, we promote to use environmental account. It's because using this account, after calculate this score in this key indicator, you could also calculate some operational indicator and make some very deep analysis on your indicator, which is more difficult when you don't use the environmental account. So I will directly jump in the first indicator. This is total energy use by the national economy. So what we want to have, this is the amount of energy that is end used by resident units of a given economy. So directly you see these terms by resident units. This is, of course, a specificity of environmental account. We only consider the consumption from residents, and we will exclude the consumption of non-resident. You will see later in my presentation why it's important, and yes, why it's important to do that, and which kind of information you will obtain if you do that. But what is important to know is that by applying this rule to only consider resident units, we will be consistent with national account. That means that you could directly, you have the possibility, in fact, to compare the statistics that you will produce with macroeconomic statistics that you obtain in national account. That's why, for example, if you want to compare the energy consumption to the GDP or gross value added, normally you should use only statistic coming from energy account. And it's not totally correct to use primary energy supply. This is an indicator that you could find at international level, but it's not totally correct because the methodological definition are not the same. From one side, we use resident principle, and for other side, the territorial principle. Come back on the definition of the indicator, the amount of energy that is end use. So what is the term end use? End use refer to the final transformation stage of human energy use. Mean that after that, it's not longer available for human use. Well, to be honest, we don't use exactly this definition in our statistics, because if we use this definition, it means that we need to estimate the energy after the final device that you have in-house, your oven or something like that. It's not exactly the same the case. What we have in energy account is that, and also in energy statistics, we use the value before the final device. And why we do that is because data availability. It's easier to use the value that you obtain in your bill for the household or for companies. This is data available that you could collect easily by survey, and by this way make easy calculation on account, and it could be in physical units, but also in monetary units. So again, you will be consistent between the statistics that you produce. So the idea is calculate the amount of energy that is used by resident units. That's a given economy. For that, we recommend to calculate a physical energy flow account. You could find the methodology to develop this account in the SEEA from United Nations. More or less, this is a supply and use table. Mean that for the use table, you will have in row the different energy products, and in column you will find the intermediate consumption, the final consumption, and the variation of stock. And this is what will interest us. In this is the end use of product. Yeah, and just to mention also that now for this indicator, we propose to use physical energy flow accounts, but there exist also monetary energy flow accounts with exactly the same format on table supply and use. And it's interesting to compare the two use table. By this way, you could calculate, for example, for a specific economic branch, an implicit price. And it's very interesting to compare the implicit price between NACE in new economy. But for today, we will keep on physical energy flow accounts. And I mentioned that you could start the compilation of the buffer by referring to SEEA, but you could also have a look to the different document and methodology proposed by Eurostat. And if you go in this direction, I must mention you that Eurostat developed a tool to build the physical energy flow account. Coming from the energy statistics, you will obtain the physical energy flow accounts. It means you will convert your energy statistic based on territorial principle to accounts based on residential principle. The main difficulties when you will try to use these tools, or if you do that by your own, is that you must disaggregate your transport use. You certainly know that in energy statistics, in energy balance, all the consumption of fuels related to transport is aggregate in one domain, one variable, which is the use for transport. In energy no account, we want to know what is the transport for each national account, each economic activity, excuse me. And to do that, there is different methods, but one method that we use in Luxembourg is, and I think it's the same for Italy, but Angelica could confirm. We create a disaggregation key coming from national account. But I could come back on that if there is some question how to do that. Based on that, we will disaggregate the transport, and what is very nice with the physical energy flow account is that when you will have your user who will ask what is the consumption of the construction sector, you could give a number for the total energy consumption, means the process, but also the transport. This is the total energy consumption end-use consumption from this NACE. As I mentioned yesterday, I present in Luxembourg. This is also our national list, and there is so much interest to know the total energy consumption of households, including the transport, to have a global view of the impact of households on the climate change. This is for the indicator. If you achieve to make this disaggregation, it's not so complicated to obtain the physical energy flow account. And if you use the table from Eurostat to present this account, you must know that the indicator that we want to obtain, the total energy used by national economy, it's already automatically calculated in the table. In the questionnaire, it's what we call net domestic energy use. This is in fact the sum of the energy losses, all kinds, and also with the energy incorporated in product for non-energy use. So the main advantages of this indicator is that you could, based on that and the energy account, make a lot of analysis, operational analysis. But the disadvantages is that because you use mainly a lot of statistics to produce this account, that the availability of this account is usually after more or less 1 or 2 years, depending your national account and your survey. And this is the difficulties, really, for policy user to wait 2 years to obtain an information. And that's why we decide in the international list proposed by UNECE to keep another indicator, which called a proxy, I will say, and this is the total primary energy supply. So the amount of energy available for use in a country. Again, this is the same unit. This is pentajoule, and it's on national territories. There is a small mistake. It's not resident units, but on territory. And to calculate that is quite easy. We take the production of the country plus imports minus export minus bunkers and plus or minus stock change. Change, in fact, but the stock change could be positive or negative. And bunkers include, in fact, maritime and international aviation. So you could see that usually in your country, these statistics are available very rapidly in the sense that perhaps after 2 months or 3 months, you will obtain all these statistics and we could calculate directly this total primary energy supply. And that's why it's recommended by international agency. It's because it's available very quickly, and also this indicator well known. But I want to recall you that there is some difference between the two indicators. First, for the total energy use by the national economy, this is based on national economy, means residence principle. We have a look to end use. And the advantages is that you could compare to macroeconomic variables like gross value added. From other side, the total primary energy use apply a principle of territory. It's not the end use is the primary supply, means that it's before all the transformation of energy and not accounting the loss that you will have during transformation or distribution of your energy. And normally, you should not compare this value to macroeconomic variables. Perhaps you could say, okay, but it must be more or less the same for my country. It depends. And that's why I want to show you the case of Luxembourg. Here on the screen, on the left upper graph, you have the two indicators. In blue, the total primary energy supply, and in orange, the total energy used by the national economy. And you see that for the year 2010 and 2014, we do not obtain the same value. And if you want an explanation, and after the trend after from 2015 to 2019, we obtain more or less the same value. Of course, you have bridge table to go from one indicator to another indicator. It's feasible to calculate from one to another if you have some additional information. And this is the table that I put on the slide. I will explain the calculation. In this case, I decide to start with the total energy use, but you could inverse the calculation if you want. So I start from energy account. I have this value in my table, the total of residual energy. And this is a value of 163. So if I want to calculate in terms of territorial principle, I need to deduct the energy use by resident unit abroad. And in this case, in Luxembourg, this is mainly air transport. We have big company who have international transport, and I must deduct the consumption of this company made abroad. This is 46 pentajoule. And after that, I need to add the energy used by non-resident on the territory. And for Luxembourg, this is mainly road transport. As I mentioned yesterday, in Luxembourg, we have a fiscal facility for fuels, and that's why there is a lot of commuters, a lot of professional road transports coming in Luxembourg to buy fuels. Of course, this is not an activity from residents, so in our energy account, we deduct this value. But if we want to apply this territorial principle, we include this value. And then we will obtain, in fact, the gross inland consumption of 189 for the year 2019 in Luxembourg. Now, if we want to obtain the total primary energy supply, we need to deduct the international aviation. In fact, we need to deduct bunkers, but in Luxembourg, we don't have maritime bunkers, so we only deduct international aviation. S23, and we will obtain the total primary energy supply and the value of 165, what is very close to the total energy use. But remember that it was not the case in the past. And to explain that, you need to look at the graph on the right. You see in orange the trends for the road transport, the consumption of non-resident for road transport on the territory. We are around 80 in 2011, and then a decrease until 2015. And concerning air transport consumption from resident units abroad, it was in 2011, not so much, to 20 pentajoule, but there is a large increase of this consumption. And it's mainly because Luxembourg become a hub for air transports and connection with China for the Europe. And you see that this increase gives that more or less we have a balance between the two, what we deduct and what we add. And that's why we have this value very close. But remember that for Luxembourg in the past, it was not the case. just an observation for recent year, depending on activities. So in conclusion, I will say that if the better is to use the total energy end use indicator. And if you don't use this indicator, take care in the case of you are a small open economy with a lot of import-export. If you have an economy with a large international company, or if your economy have some tax advantages on energy product. In this case, what you will obtain and the trends that you will obtain with your proxy, the total energy supply, will not exactly the same as the indicator proposed. And that is for me, Angelica, and give you the floor.
Excuse me, Angelica, it seems we don't hear you.
Okay.
Okay.
Okay. Thank you
Now
very
it's
much,
good. Thank you.
Gosha. Thank you. Yes, now I was trying to propose to Olivier if we can continue with his screen. Maybe it's easier, given that he's already sharing it. And we can proceed with the two other indicators that, as mentioned in the introduction, we selected for this presentation. As you can see immediately from the name of the indicators, we are now shifting from absolute numbers. Up to now, we talked about total energy use, so one measure of the amount of energy that is used in the country. And now we are talking about intensity. So we are talking about ratios. So we will have something to be measured as a numerator and something else as a denominator. So of course it becomes crucial in order to have a meaningful indicator to have a numerator that is as consistent as possible with the denominator. And this is exactly this consistency that is needed when you use ratios is exactly what you can achieve best, as Olivier was also explaining, with energy flows calculated on the basis of environmental accounts. Let's see in detail what we mean. The indicator we will talk about first is the total energy intensity of production activities of the national economy. So what we want to measure in this case is the amount of energy that is needed in a country to produce a unit of output. So what we have is the ratio between a physical measure of energy consumption, of energy use, and a monetary measure of the goods and services produced by the economy. And now this is why the consistency between numerator, energy use in this case, and the denominator becomes really important. And because you are measuring two things at the same time. So this is why when you calculate energy intensity by means of energy flows derived from environmental accounts, you achieve this consistency. And so this is why these kind of indicators of energy intensity are best calculated from the accounts. I am sure, however, that you came across other measures of energy intensity also calculated on the basis of energy statistics and not from the accounts, simply because energy statistics are more available, more widespread than energy accounts. So these can be a proxy calculation. You can achieve a proxy calculation if you don't have energy accounts yet. So let's say in a transition phases. Also, another thing, of course, to notice is that the indicators we are proposing here refers to total production activities of the national economy. Of course, you can have, and I'm sure you also came across as a user or as an expert in the field, other measures of energy intensities. They might refer to the entire economy or to an individual economic activity or to a grouping of activities, let's say the entire manufacturing sector. But in this case, our interest is for total production activities. Of course, sorry about that. Of course, this indicator is important for measuring the distance from existing national energy efficiency targets, and there is a certain relationship between the indicator we propose here and another indicator that is used for similar purposes, that is the SDG indicator 7.3.1. But then again, it is important to understand that although there is a certain relationship, they are not actually the same, because as you can see in the slide, the SDG indicators 7.3.1 measures energy intensity in terms of primary energy and GDP. So of course the denominator is the same, but the difference lies in the numerator that is based again on energy statistics. And as Olivier was explaining previously, there are important differences between the two. So of course, these differences will be reflected also in the ratios, of course. So we saw before the example of Luxembourg, how numbers are likely to be different depending on the importance mainly of transport-related energy flows. Of course, if you measure the intensity on the basis of one indicator or the other, then you will have a difference in the intensities as well. That's also quite obvious. So SDGs, again, SDG-based indicators can be a proxy in a transition phase if energy flow accounts are not yet available, but the final objective, again, to achieve full consistency between the energy flow measurement and the economy and the measurement of economy-based values has to be based on energy accounts again. Okay, now, as you can read in the slide again, what is suggested for the calculation is to use as a numerator the intermediate consumption of energy products of production activities. That would be in terms of ISTAT classification, total industries, with the number assigned to industries by ISTAT. That would be from 1 to 99, and that of course would be a physical measure, so terajoule would be used, whereas for the denominator we would use gross domestic product, and if we are calculating a time series, then we have to make sure that the calculation is in purchasing power parities or in constant prices. Now, the story I would like to tell you about our experience with the calculation of this indicator, and I would like to ask Olivier to show the next slide, please, in respect to that, is that when last year we started to actually produce the numbers, then we questioned a little bit this proposed calculation, and after some further reflection, we decided to change the methodology slightly. This was the reason for this proposed change. Of course, the GDP is a net concept, as you know, is a net concept with respect to, because it doesn't include duplications. It is obtained from output by deducting the intermediate consumption, so there is no duplication of economic value by construction in it. And whereas the proposed numerator, that is the sum of intermediate consumption, is a gross concept, because you have all the entire use of energy products, and that includes duplications, because you can have a primary energy products and then the secondary products obtained by it when it is transformed by the economy. So we thought that again, to have full consistency between the numerator and denominator, another measure could be used for the numerator that would be a net concept. And for this reason, we, in our calculations, we used net domestic energy use for energy purposes that, in the case of our country, can also be derived from physical energy flow accounts. You can see in the slide the exact indication of where to find this indicator, but of course this is not very useful for countries that do not have physical energy flow accounts in place. But in any case, the message would be also to think about the possibility of using a net concept of energy use in which duplications are not included, rather than a gross one. Of course, you can use the indication that is now in the metadata, but this is also to say that when you actually calculate the indicators, further reflections come to your mind, and that might also possibly start a new dialogue also for with the task forces that are discussing the development of the indicators, and that might result in the future in a change or not, depending on whether the proposal is accepted, of course. Now we can We can go to the next slide, please. Okay. And you can see here the the last indicator that we have selected for this presentation. Again, this is also an intensity indicator. So we have a ratio here as well, but unlike the previous case, we have the ratio between two indicators measured in physical units. What we want to measure in this case is the pressure exerted on the environment in terms of CO2 emissions for each unit of energy that is used for production purposes. So we have again the CO2 emitted by production activities in the numerator, and that is divided by how much energy is used by the same production activities. And that again is derived from accounts. The numerator is derived from air emission accounts, and the denominator, of course, is derived from physical energy flow accounts. And again, as with all the indicators we are presenting, they refer to the national economy as a whole, in this case, production activities as a whole. But of course, you can calculate with reference to a breakdown of economic activities as well, to an individual one or a grouping. And of course, this measurement, how much CO2 is produced for each unit of energy used, is really important to understand how much the economy is achieving, is progressing towards reducing CO2 emissions. And of course, this might be due to the kind of energy mix that is used in production processes. Over time, you might change this mix and so manage to achieve a reduction of intensity that is emit less CO2 per energy unit. And of course, apart from changing the energy mix, there might also be a shift from this change in energy mix might be due to the composition of fossil fuels, or to a shift from fossil fuels to renewable energy sources as well. Of course, you might have noticed that the denominator, that is the measurement of energy use, is the same as the numerator of the indicator we saw before. So in this case, in the case of metadata proposed, the denominator would be measured in terms of intermediate consumption of energy products of total production activities. But of course, based on what we said before, if you use a net measurement of energy flows, then of course also these indicators should be measured consistently. So depending on how you actually measure energy use, of course, this indicator would change as well. Next slide, please. Okay, similarly to what Olivier also has done, I would like to present you the way we disseminated the indicator in one of our publications. We wanted to present them together. And as you can see, these data, of course, refer to Italy. So you can see that in 2019, which is the final year of the time series, for 1 million euros of GDP, we needed in 2019 a quantity of energy that was 19% less than the quantity of energy we needed at the beginning of the period, that is in 2008. And each terajoule of energy used for production generated 16% CO2 emissions less. So, of course, there has been an improvement both in terms of energy intensity and in terms of CO2 intensity of our economy, and that is due in our case both to the reduction of the share of fossil fuels in energy consumption and to the substitution among fossil fuels with less CO2 emitting fuels becoming more and more used. Okay, and with that, we would like to thank you for your attention. And of course, you can always come back to us for further questions you might have. Thank you very much.
Thank you very much, Angelica and Olivier, for this very interesting presentation. And as Angelica mentioned, if you have any questions, you can put them in the chat. We already have one comment from Naira from Armenia. So please keep them coming and we'll look at them after the break. And now we will move on to the second presentation. So I invite the Tegshjargal Tsagaan from NSO Mongolia. Tegshi is currently the Chief of Division of the Money, Finance and Service Statistics Division in the Economic Statistics Department of the National Statistics Office in Mongolia. And prior to this assignment, she was a senior economist statistician responsible for compilation of institutional sector accounts, input-output table, and the compilation of the SEEA accounts. She has been working in the NSO for the past 27 years. And Tegshi, you have the floor. Thank you.
Hello.
Hello, we can hear you. We don't see you
Okay.
yet, and we don't see your slides. So,
Okay, I will share it now.
thank you.
Can you see my slide now?
Yes, we can.
Okay. Hello, everybody. I'm happy to share our experience with you. Today, I will discuss with you the Mongolian experience to produce some climate change related indicators from the energy accounts. But this doesn't. Okay, this is my presentation's outline. Firstly, I will share you a brief introduction about the SEEA implementation in Mongolia. Then I explain the framework and structure of the energy accounts, compilation methodology, and the data source. Finally, I introduce some indicators which are coming from energy accounts. The National Statistical Office of Mongolia is implementing the SEEA in a step-by-step approach. The UNECE has developed the following sub-accounts, such as economy-wide material flow accounts, physical flow accounts for energy, environmental tax accounts, and the environmental protection expenditure accounts. And those are being compiled annually. Also, we plan to compile the solid waste accounts, air emission accounts, and water accounts starting from this year. Usually, when we start to compile accounts, first we study the international guidelines and handbooks. Then we have been developed the national methodology and approved by Chairman's Council. The physical flow accounts for energy was first compiled for 2015 and 2016, in the first time in 2018, in the framework of ADB project, strengthening capacity for environmental economic accounting. The energy accounts make it possible to develop climate change related indicators as well as energy efficiency indicators where economic data and energy use data can be directly combined. This chart shows the physical energy flows. The energy flow consists of three main parts. The first one is energy from natural inputs, energy products, and energy residuals. The energy from natural inputs are the flows of energy resulting from the extractions and capture of the energy from the environment. These flows include energy from energy resources like oil, natural gas, and coal, as well as inputs from the renewable energy sources, for example, solar, wind, and hydro. The primary energy products are captured directly from the natural resources. The secondary energy products have been transformed from the primary energy sources, such as electricity and refined petroleum products. Both primary and secondary energy products used in the final use. When we compile the physical flow accounts, we use these two standard methodology. The coverage is the same as national accounts. The energy physical supply and use table covers all sectors of ISTAT, plus the energy production and use of households. Estimates for coal use in GIR areas, GIR means our traditional dwelling, GIR areas have been made for UP, capital city, but now total energy use and unused production of energy for all households in Mongolia have been estimated. For industry breakdown, we use ISTAT revision 4 is used. For developing the list of energy products, the HS classification at 8 digits is used as a starting point. In addition, we use standard international energy product classifications. This chart shows the data source. We have used multiple data sources. So first, we have an internal data source. This is annual industrial statistics. We have three types of balance. The first one is balance of electricity, balance of terminal energy, balance of cost, and also we have a monetary supply and use table. We use these data for the internal data source. Also, we use the administrative data source. This is mainly used in the external trade database and tax database. Also, we use the database, not it is internal database. This database comes from the electricity and heat distributing companies and also a VAT register database. As well as we use the business register. From the business register, we can get list of companies which are engaging in energy sectors. Then we use the census and survey results. We conduct the livestock census in every year, and we also conduct the household socioeconomic survey. From the survey, we can get some information. Here I elaborate about the survey. Also, we conducted a special survey for energy accounts. Then I will elaborate this survey. The survey is using those 6 forums. The first one is importers. In this survey, we want to know what they are purchased and sold to whom. Also, we conduct the survey electricity producers, thermal heat producers, and coal mines. Sorry about that. For this survey, we want to know how much they produced and sold to whom. Also, we conducted a sample survey for agricultural agricultural, manufacturing, construction, and water sewerage industries. So for the database and registers, we want to figure out who is using these, these energy products. Electricity distributors, heat distributors, we can get the database. The database was collected from the 12 companies that distribute electricity and the thermal energy to users. This is the main source for the total use of electricity and heat by industries and households. The next database is VAT register. This VAT register, we want to get the share of industries in consumption of each petroleum products like fuel, diesel fuel, lubricants, and LPGs. Calculation for households in living areas. We have 3 types of households. First one is nomadic herders households. To estimate the own use production, heat, and electricity based on data of livestock census. We use livestock census data. We get some indicators such as number of solar panels, number of equipment which is used by nomadic households, such as TV, refrigerators, computer, etc. The households living in areas in rural. The households in rural areas use a variety of different sources of energy for producing electricity. Something like from solar panels and heat for heat and firewood and dung and coal. Households living in areas in urban. They are living in area in urban areas use solid fuels for cooking and heating. The compilation of the physical flow energy accounts allows the UNECE to estimate the use of energy products, coal, electricity, thermal energy, petroleum products, fossil fuels by industries and products, and it also enables the UNECE to estimate the energy use of nomadic households as well as households living in the gear areas in the capital city and the AMEC centers. Moreover, it also explored new data collection methods, especially the use of big data. And this is the from suppliers database of electricity and thermal energy from the VAT registered database on the purchase of petroleum products and the local government tax, etc. The use of tablets in the survey to collect data in UP capital city areas demonstrated that the tablets are the most suitable tool to compile data in the urban areas. In addition to developing new data collection methods, the physical energy flow account will lead to the development of the national conversion factors for the different types of coal in Mongolia. We have main two types of coal in Mongolia, hard coal or brown coal. A sample survey was conducted covering the supply and use of energy products plus gross ores from the mining enterprises. A national list of energy products has been developed and can be used in the future. This table shows our last results. We just compiled our 2020 energy accounts. For the supply side, we have from natural inputs and energy products and residuals. Another use side, industries use the primary inputs from the environment. Also, the energy products, they produce the energy residuals. For household, only use the energy products. Also, there is some accumulation. This is mainly the coal, and we exported the coal to rest of the world. These are our results. So this is the main result from the energy accounts from 2015 and 2020. If you see this graph, there is the supply of primary energy is the big component of the total energy supply, and the supply of secondary energy is the small part of the total supply, and we have imports. For the total energy use, you can see from this graph, the most energy use is going to the abroad. We exported the coal to the China. The second part of the energy use is the energy used by industries. The energy used by household is the smallest one. So I want to show this table. Just want to which products are included in the energy accounts. First three products: hard coal, brown coal, crude oil is extracted products. It is from the environment. So in green products, it's imported products. It's mainly the petroleum products. Petroleum products, the 100% from the imports. The third part is the blue one is the produced products. This is the structure of the energy products for the accounts. So now we start the climate change related indicators. After we compiled the energy accounts, we estimate those indicators. First one is the total energy used by national total. This is the Tegshjargal. If we see this table, the energy used by national economy is lower than the energy used for export. It is about the 46.7% of the total use of energy is the use of the national economy. 53.44% of the total energy uses goes to the export. If we see the chart, graph, the diagram, this shows the structure of the use. So energy used by industry is 36.3. This is for intermediate consumptions. Household energy use is 7.1. We have a little bit change in inventories. This is 2%. There is also some energy losses. This is the 1.2. If we see the energy used by industry breakdown, the manufacturing sector is used 19% almost, and electricity, gas, steam, and air conditioner supply activity is used 9.1%, and agriculture is only 0.1%. Mining manufacturing is 3.8%. Other sector is 4.5%. This is the use structure. The next indicator is the total primary energy supply. You can see the total primary energy supply is going down in 2020. It is because of the COVID-19. Some extraction company, they didn't operate, so the supply is going down. So the next table shows the total primary supply by type. You can see from this table, most of the natural inputs come from the fossil, non-renewable natural energy inputs. The hydro is small, wind energy input is small, solar renewable energy inputs so small. We have also biomass-based renewable natural energy inputs. This is increasing because we have a lot of animals and grass, so that the biomass-based renewable natural energy is a little bit higher than other renewable energy. The next indicator is the total energy intensity of production activities of the national economy. The energy intensities reflect the country's efficiency on energy use, which is calculated comparing energy use to the GDP in given period. For energy intensity and energy productivity from 2015 and 2020, energy intensity increased, but the energy productivity decreased. More especially, Mongolia was using 12.9 gigajoule energy to produce 1 million GDP by industries in 2015, while it became 70.2 gigajoule in the 2020, and increased by 33%. And this table shows the total energy intensity of production activity of the national economy. For Mongolia, the most energy intensive industry is electricity, gas, steam, and air conditioning supply sector, while the least energy-intensive industries are agriculture and service sectors. Also, we produce the SDG indicators 721 and 731 from the energy accounts. You can see here the renewable energy share in the total final energy consumption is very low. Only 1.2 of the total energy consumption is the renewable energy. The energy intensity measured in terms of the primary energy and GDP constant is the increasing until 2019. So in 2020 it's decreased. It because of the extraction company. As well as we produce other main indicators from the energy accounts. This is the domestic energy use per person, also domestic energy supply per person. So thank you very much for your attention.
Thank you very much, Tegshi. That was extremely comprehensive, very, very interesting. And now we go to the next presenter, that is Peter Meadows. So I invite Peter to the floor, and while he's being connected, I will just tell you that Peter is the project manager for Land, Oceans Ecosystem and Tourism Satellite Accounts in Australia. He has about 20 years of experience on environmental economic accounting on a range of different accounts, including energy, water, land, and fish. He's part of the technical committee of the revision of ecosystem accounts and is generally learning more about environmental economic accounts every day. He says he has possibly the best job in the Australian Bureau of Statistics. So, Peter, you have the floor.
Thank you for that. I will try not to cover much of the same information as what Tegshjargal has covered. She did a really good job explaining how the accounts are pulled together and what direct products you can do from that. So I will go through pretty much what Australia is doing in this space at the moment. So I'll try and focus my efforts on what Australia's energy and climate indicator needs are, and how these are best represented using the SEEA and other information sources that we tend to produce. As a part of that, I will also talk about some new and experimental projects that we're initiating at the moment. The three things in this presentation will be on energy, greenhouse gases, and oceans and ecosystems. And they will all lead towards thinking both around what are the components of climate change and also what are the results of those components of climate change, as well as what can we do to mitigate or adapt to some of those drivers and impacts of climate change. The main goal of SEEA-based indicators is really to show what the actual trends are in terms of the data. It allows a really good comparison with national accounting and those sort of measures to reduce gross domestic product or GDP. But it also is a way, and possibly one of the most important things that we do, is having an open and transparent set of methods that develop indicators from a series of data all the way through your accounting structures to those sort of indicators that are used by the general public, by ministers, and you hope by those people who are making important policy decisions in your country. This graph is one of those indicators we tend to produce. It covers both energy and industry intensity and annual energy use per household. The left-hand side is the amount used by households, and the right-hand side is that intensity from industry. You'll note here we use gross value added as a factor for our intensity measures. The reason for that is it is a better reflection of, I guess, the internal use of energy within the country. Australia has a very high level of exports of energy products. Coal is one of our favourite products in particular. So this gives us a better indication of how much domestically, or at least by residents, are being used for every dollar of gross value add in Australia. As you can see, we are steadily decoupling, despite probably media reports and other information that comes out on occasions. The next two slides are based on a training course that we run for policy and for people who want to start learning how to produce SEEA accounts. We use this information to demonstrate the sort of power of the environment economic accounts and how it contrasts with other information and data sources that are commonly used within government and for international reporting. This slide in particular is based on the International Energy Agency's energy balance method. It consolidates activities within an economy to a broad sector view. And it really, you can see it consolidates auto gasoline, which is petrol, and diesel into these sort of road transport activities. Now, if a question we would hope comes out of policy, and we have actually seen it in Australia, of how do we minimise our impact on climate based on transport, these two fuels are the obvious ones that we should try and influence. And if you looked at this graph, you would probably think that aiming all our attention at the transport industry would probably be one of the best things that we could do. So either through tariffs or taxes on petrol, and potentially through subsidies to minimise or at least increase the efficiency that we use our diesel. However, if you take a SEEA approach, where you actually allocate that consumption of those fuel types to the industries that are actually purchasing them, you get this sort of picture. And transport and storage services is about the fourth one from the right-hand side. And you can see quite quickly that if we applied tariffs and taxes on petrol to transport industries, it would be quite unfair. They don't actually use a great deal. And if we were to give them vast amounts of subsidies to sort of improve the efficiency of their diesel, while I suspect the industry would welcome this because it'd be quite a substantial amount, it may be better off actually applied across other industries, such as mining, which is the second one from the left, and our agriculture industries, so for crop harvesting and so on. And the really interesting one is the one that's second from the right-hand side, which is our households. Our households are the major consumers of transport fuels in Australia. And so any changes to policy or changes to the settings that we use to manage those fuel types would severely impact on households, which is in some cases, and as we've seen in Australia, could be quite a bit of a political challenge. We produce the energy accounts every year. They come out 18 months after the reference year, which is probably not the best, as Olivier mentioned before. We use a wide variety of data sources to produce this. We mainly try to be coherent or consistent with the energy balances for Australia. So we have quite close relationships with our Ministry for Industry and Energy, who produce the energy balance data. We feel that it's best off being coherent or at least consistent with their numbers due to, I guess, ensuring that there is certainty or trustworthiness in our data between the two agencies. And they also collect quite a substantial amount of data. Our Australian energy balance data has been largely collected since the early 1980s. The energy accounts have been constructed since the late 2000s, so 2008-9 was our first year. But we have time series data back to 2002, 2003. Our financial years are on a June basis. We use survey data, as you saw before, to allocate, I guess, different fuel types to industry. We use administrative sources of data. In Australia, we have a national greenhouse and energy reporting system, which companies must report when they cross a threshold of 100 terajoules. They need to report their fuel consumption, the type of fuel, what scope that fuel is, as well as any renewable sources of energy that they produce, plus carbon emissions are also calculated as a part of that system. It covers 85% of our energy use in Australia, which is quite useful. We also use trade data. Again, Australia is a very heavy exporter of energy products. And we use sort of other information from our energy market regulators to get a good feel for how the market is actually moving and whether or not there's any substantial changes in production of energy in particular. I'll now move on to some of the greenhouse gas emissions that we produce on a regular basis. The Australian Bureau of Statistics does not produce greenhouse gas emissions data. Our Ministry for Industry and Energy produce these numbers. It's a part of the UNFCCC reporting requirements under Kyoto and then Paris agreements. And it's seen to be a powerful enough indicator that it's held within sort of the policy areas of government rather than handing it to the National Statistical Office. Saying that they're seen as some of the best in the world in terms of their ability to produce emissions. And as you can see from this graph, emissions per capita basis and per dollar of GDP seem to be reducing, but you need to sort of then realise that Australia has had 20 years of virtually uninterrupted growth until COVID, and 20 years of almost uninterrupted population growth as well. So you need to sort of take that into account, and you don't quite get that from this graph. There's a number of policies that government use which are quite useful for us in some respects because they form new sources of administrative data. We have an emissions reduction fund, which is an auction for carbon units in Australia. Companies will bid for a value of carbon and have particular projects which will be used to sequester carbon. This is a good source of those companies that are doing that activity in terms of carbon sequestration, but also has an effect on giving us a partial value of carbon and carbon storage services, which we'll discuss a little bit later. The government also tends to let the market sort things out here in Australia. Solar panel uptake here in Australia is on a fairly massive scale. And in fact, we are now getting some of our regional jurisdictions are producing more renewable energy from solar and from wind than sort of the more thermal and non-renewable energy sources, especially when we have nice strong winds down south. And Australia is one of those countries that has about 200 to 300 days of sunshine every year, which makes it quite useful. As I mentioned before, the name has changed from what you see at the top there. It's now the Department of Energy, Science, Industry, Energy and Resources. They produce our national greenhouse gas inventory on an annual basis under obligation to the international organisations. We also produce quarterly estimates, and these are based on the International Energy Agency, and they have a wide range of data, from collecting information directly from businesses and from producers of energy, as well as some modelling systems to produce some of the more quarterly estimates. They do produce an industry or an ISIC-based estimate once a year, which is quite useful for us because we can then test to see whether or not the numbers that they're producing on a territorial basis, how they compare to what adjustments you would make to get it to a residential basis. And at the moment, the difference between territorial and residential is about 2%. So it's quite small, and we tend to, as a national statistical organisation, think that it's probably okay to just use those. The ministry use a system called the Full Carbon Accounting Model. It consolidates energy information. You can see from the top there, going around the right-hand side, it includes transport information, water, data on wetlands, data on forests, data on land and wood products. Land, forest and wetlands are primarily the human-based changes to those systems. So where there's been disturbance based by human hand. Wood products are important because it's a useful storage of carbon. Once you chop a tree down and turn it into a piece of furniture, it actually is quite a good store of carbon, unless you decide to burn it every year. And energy, transport and water are those components which are quite variable and will change from year to year, especially as Australia is quite prone to extended droughts and extended wet periods. I'll now move to something slightly new. Australia, as a part of the high-level panel for oceans, has made a commitment to start measuring ocean ecosystems and to have plans to manage marine environments within about 5 years. We've been approached by our Ministry of Environment to focus in on blue carbon ecosystems as a first look at whether we can measure ocean ecosystems. And this is quite useful because it allows us to focus in on the carbon-based elements. And these are some of the results that we likely produce from those. So maps of where the blue carbon ecosystems are located, probably the stock tables that you see within the SEEA accounts, especially the central framework and the new ecosystem accounts that have been ratified last year, as well as thinking about more sort of regional representations of that information. Blue carbon ecosystems are far and few between here in Australia. There's not that many of them. We're focusing in on mangroves, seagrass, salt marsh and coastal marshy areas, and large kelp. And in that, we're going to be producing a number, or at least a range of information. For climate change, it's really what are those areas that have stocks of carbon and how much are they storing, how much carbon they're sequestering every year or how much they're storing every year. And then thinking about sort of an adaptation side of the ecosystem. So for some of the ecosystems, how much of the coast are they protecting, and what's the value of that coastline that they're protecting? And the protection is really from things like rising sea levels, inundation or flooding based on storm events. Australia is quite prone to cyclones in our northern regions, or hurricanes, depending on which side of the country, side of the planet you come from. And with the innovative thing that we're choosing to use this time around in developing our account is that we're using a system called human-centered design. And this is really where we have a discussion with our stakeholders. We gain knowledge about what they're trying to change or the outcomes that they're trying to manage, how they're actually going to use information. So are they going to use that information for reports, for information to give to stakeholders or community, for modeling? And then as we build the accounts and the outputs that come from those accounts, talk to these stakeholders over a number of occasions to find out if these data and these outputs that we're producing are actually fit for the purpose that they're intending. What's next for Australia? There's a couple of areas that we're looking into at the moment, or at least from a national statistical organisation point of view, have a bit of an interest in. There's a lot of discussion around whether we can create a low emissions economic account. So this is really recrafting the system of national accounts to think about those businesses or products that are either produced or are involved in the minimisation of greenhouse gas emissions in the economy. There's a report there that you can search up if you want to find out more. We're also quite interested in, I guess, the structural changes or the consumption and behavioural elements of energy and greenhouse gas emissions. The two main areas where we see interest is on the supply side or production of energy, and really looking at measures that decompose or have a look at the whether structure, activity, or efficiency or technology are main factors in the change in energy or greenhouse.
Excuse me, Peter, it seems like we stopped hearing you. Excuse me, Peter, can you hear me? Sorry, Peter. We cannot hear you. I think Peter is okay. He's reconnecting. We still cannot hear. Perhaps there is some issue with your headset. So we will try to contact Peter. Please bear with us for a second. Peter, can you hear me now? As we still seem to have problems with Peter's audio, I would suggest that we now take the break, which was scheduled right after Peter's presentation. and hopefully we can still reconnect him for a couple of words after that, unless Peter, you are up and running right now. Seems not. So in that case, we are going to have a little less than 10-minute break. So please do come back at 10:49, and during right after the break, we will have a few words from Peter, and then we'll try to handle the questions. Peter, was that you?
Something happened. Did something happen there? I take it because
Oh
I was on
yes,
a
yes.
lovely spiel. My audio disappeared. Did it? Oh no.
Yes, it was gone, and you did not hear us when we were telling you there is
No.
no sound. So in that case,
Dang.
yes. So sorry, we try to make a break while trying to
Well,
reestablish your connection. In that
I was
case, would you
happily
like
chatting
to?
away there.
Yes, sorry about that. Would
That's
you like to
hilarious.
say a few words to wrap up?
Yes.
We lost also your presentation now, so you have to.
Oh no. Oh well. Stay tuned for a YouTube clip on energy and greenhouse gas emission indicators from Australia, and I'll post it to you. Dear,
All right.
my apologies for that. I hadn't realised that my system would cut you out. No. Just to wrap up, yes, Australia is looking at managing energy accounts on a regular basis. We have a wide variety of data sources that we use, in particular administrative information, and making sure that we're aligned with energy balances. Our greenhouse gas emissions are produced by, again, another ministry, and they seem to do a fairly good job. In fact, they're well recognised. And we're moving into carbon-based or blue carbon ecosystems here in Australia as a response to the high-level panel formations. Yeah, I would fully encourage you to invest in SEEA indicators, because it does help you to better target policy, especially for transport is a classic example. And my apologies for that all disappearing. I'm not quite sure why.
Yes, maybe we'll never know. Thank you so much for concluding this. You were already at the last slide when it stopped working, so I hope we did not lose much.
Okay.
Yeah, thank you. Thank you so much, then. So we will now move on to the break. Please, let's be back from the break 10 to 11. And during the break, please put your questions to our speakers on the chat, but also answer a question in Mentimeter yourself, and that is going to be used for the panel discussion at the end of the session. So on your screens, you should see now the question and the QR code. So please do that, and we have a break until 10:50 Central European Time. See you in a moment.